Hello everyone, welcome to Mathz Life. So today we are going to do our important questions for IPE supplementary examinations. So let's start. So what we have first here is reduction formula for integration of sine to the power of nx dx. So my assumption is this question will come in a IPE supplementary because they didn't ask reduction formula in the IPE main exam. So let's start with our first reduction formula, which is integration of sine nx dx. So what I will do is we will take it as equation number 1. We will just mark it as I of n. What I will do is I will just multiply with sin x in the numerator and denominator on the right hand side. So what it will happen, sin of n minus 1x sin x dx. Basically what happened here is the sin x in the denominator came up with an minus inverse function. So it becomes sin of n minus 1x. What I will do is I will apply by parts here, by parts rule. So the sine to the power of n minus 1x become the first function and sin x become the second function. So what is the formula for by parts? Integration uv, that is equal to u into integration of v minus integral of u dash integration of v. So we will apply the formula. We get it as sine of n minus 1x integration of sin x dx minus integral of d by dx of sine of n minus 1x dx integration of sin x dx whole dx. So we know that integration of sin x is minus cos x, and since d by dx of x to the power of n is n into x power n minus 1, here we will apply chain rule. So we will differentiate sin x, we get cos x, and integration of sin x is minus cos x. So we simplify this whole equation, we get the minus came out, minus of sine of n minus 1x cos x plus n minus 1 integration of sine of n minus 2x cos x cos square x. So what I will do is we will apply the trigonometric identity cos square x equal to 1 minus sine square x. We will apply it here. So what we will do is we will take multiply this integration of sine of n minus 2x inside. So we get it as the integration of sine of n minus 2x minus sine of nx dx. What we will do in the next step is we will just use this first equation to write this in a simple manner. What we will do, we will just substitute here n as n minus 2, so that we can write this integration of sine of n minus 2x dx as I of n minus 2, and this integration of sine of nx dx as I of n. So what in the next step, we'll just multiply this n minus 1 inside. We get it as n minus 1 I of n minus 2 minus n minus 1 in. So in the next step, we will just send this on the LHS. We take the I of n common here, we get 1 plus n minus 1, 1 gets cancelled, we are simply left with n. What in the next step, we'll just send this n in the denominator here. So now we got the reduction formula. So if you do this, you get as 6 marks. Next up, you get a attached problem, that is integration of sine of, they will change the powers, I don't know what they will give, but we will take for example integration of sine of 4x. Okay, I will tell you in the last part of the video. So next we are going to do the reduction formula for integration of tan power nx dx. Same process, we'll take this as equation number 1 and we'll mark it as I of n. So in this question we will just multiply it multiply and divide with tan square x. So what we get, I of n equal to integration of tan of n minus 2x as tan square x dx. Next up, we will apply secant square x minus 1 here, which is a trigonometric identity for tan square x. So after multiplying this inside, we get it as integration of tan of n minus 2x secant square x dx minus integration tan of n minus 2x dx. After that, we will apply this shortcut formula, which is integration of f of x whole power n into f dash of x dx. We can simply write it as f of x whole power n minus 1 by n plus 1 plus c. Okay, we'll apply it over here. We get it as tan of n minus 1x by n minus 1 minus, by using this equation, we can write integration of tan of n minus 2x dx as minus I of n minus 2. So here we get the reduction formula for integration of tan to the power nx dx. Okay, so next in the third one, we are having the reduction formula for integration of secant to the power of nx dx. In this one also, we are going to apply the by parts rule, but before that we have to multiply this with secant square x, multiply and divide with secant square x on the RHS. So after applying by parts, we can simply see that this equation is turned into this equation, which is secant power n minus 2x tan x, okay, minus integration of n minus 2 secant to the power of n minus 3 x secant x tan x into tan x, which is tan x d by dx of secant x tan x into tan x, tan square, we can write it as tan square x. In the next step, we get as secant of n minus 2, since this is plus 1 minus 3 minus 2, okay. So next up, we'll apply the trigonometric identity for tan square x, which is secant square x minus 1, okay. After that, we will multiply the secant to the power of n minus 2x. Inside, we get n minus 2 integration of secant to the power of nx dx. Minus 2 plus 2 gets cancelled here. Plus n minus 2 integration of secant n minus 2x dx. Next, what we will do is, we will just use this first one, which is first equation. Write it here. So, by using this equation, we'll just write it in simpler method, that is I of n. And this is I of n minus 2. So now in the next one, we will just send this n minus 2 I of n there, so that minus becomes plus, and we will take the I of n common here, so we get it as n minus 1, okay. We get it as I of n into n minus 1. In the next step, we'll just send it in here in the denominator, so that we get the reduction formula for integration of secant power nx dx. You might be thinking that I haven't included the reduction formulas for cos x, cosec x, cot x. So if you do these 3 reduction formulas, you can easily try the remaining 3, because they are also done in the same manner. So I hope this video will help you in a great manner. So study hard and you will literally crack the exam, okay. Thank you.